Section 1.3, graphs of functions. We're going to look at two specific functions today. We're going to look at the absolute value function and then step functions, specifically the greatest integer function. Let's go ahead and get started. Absolute value functions is the distance from 0. So when you plug something in for x, you're looking at how far it is away from 0. So the first one we're going to look at is called the parent function. This is your most basic absolute value function. And if you know what this looks like, you can really go ahead and graph it. But what we're going to do is we're going to either use t-charts today, or we're going to use transformations, or possibly even the graphing calculator. So we want to plug values in of negative, positive, and 0, and then the outputs are going to be the distance from 0. So we are going to get a V-shaped graph for absolute value functions, which is really a piecewise function of two lines. Change this real quick. And so this will be the parent function for an absolute value. And then any other absolute value function beyond this is really just a transformation of that, whether it gets shifted left, right, up, down, reflected, or stretched. They're all going to look like that function specifically. If you choose to use the graphing calculator, when you go to your y equals, the absolute value is underneath math, and mine looks a little different on here, but it's still the same on yours. You go over to NUM on the top, and then the first one is ABS. So when you press that, you can just press the absolute value. Make sure you close the parenthesis where you need to, and then go ahead and graph it. And once again, mine looks a little different, but it's still the same idea. There's your absolute value graph. And so if we go to a couple of these, you might want to pause it and just try these on your own for now. But the first one is the absolute value of x minus 2. So if you're going to use transformations, understanding that this actually just shifts the graph down 2 units. We'll have a lesson on transformation, so if you don't remember some of these things, that's fine. You just won't be able to really use transformations when you graph them. So if it gets shifted down 2, every point gets shifted down 2 from your parent function. So what I did was I just took all those points that we just plotted from the parent function and shifted them down 2. Like I said, if you don't like that idea, you can always once again do your t-chart and plug in values. Just make sure you get the V-shaped. So this would be 2 minus 2 is 0, which you saw that by shifting down 2. Negative 1, negative 2, and then it repeats negative 1 and 0. Or, once again, other option, this one was the absolute value of x minus absolute value of x and then minus 2, and then you graph and you can see that the graph got shifted down 2. And anytime you're graphing, I'm definitely going to want specifics. So if you go to the table, it'll give you values. Now this table on my calculator for some reason is starting really high, so I'm going to change it, and if you need help on yours, let me know. But so now you can kind of see some better values there, and you can plot all those on your graph. Don't necessarily need all of them, but so here is the absolute value function of the absolute value of x minus 2. And then on the second one here, a couple things going on. It does get shifted left 3 units. There is a vertical stretch by 2, and there is a reflection over the x-axis. So we got kind of 3 things going on here. So once again, if you feel comfortable doing that, using your transformations, that's fine. If not, when you go to do your t-chart here, you're going to have to make sure, because it does get shifted left 3 units, negative 3 plus 3 is 0, and that's where you want your middle value to be. So I would say x, g of x, but make negative 3 your middle point, and then you can pick some smaller values and some larger values. And then once you plug those in, negative 5 plus 3 is negative 2. The absolute value of negative 2 is 2. 2 times negative 2 is negative 4. And this should be symmetric. So when I plug in negative 1, I get the absolute value of 2, so it is still negative 4. When you plug in negative 4, that's negative 1. 1 times negative 2 is negative 2. So you can see that stretch of 2 happening right now. And then at negative 3, you're going to get 0. There's your symmetry. And once again, you have the other option to come over here and plug in negative 2. Once again, it's under Math, NUM, first one, ABS. And yours I actually might put in the absolute value bars, which is fine. And then x plus 3. Here's the graph. You can see where it's located, 3 units to the left. It's reflecting and it's stretching down. Or stretching, vertical stretch. And so if you go to your table, I'm not sure why on mine it starts at weird places, but there are some of those points that we have just discovered as well. So we did the negative 5, negative 4 for x, and then we got the 0, negative 2, negative 4. And so if we plot those points, negative 5, 1, 2, 3, 4, 5, negative 4, negative 4, negative 2, negative 3, 0, and you can see the stretch that is occurring on this one by a factor of 2. It's going 1 to the left, but then stretching vertically by 2. And so there you go. And once again, when you're graphing these, I don't want just a sketch. You have the technology, you have everything that you need to make this as accurate as you possibly can. So that is the absolute value function. The second one is called the step function, and this is the one we're going to use is the greatest integer. The greatest integer function is a step function denoted by double brackets for the x and defined as the greatest integer less than or equal to x. The greatest integer less than or equal to x. Okay, so if we have a number line and 0, 1, 2, 3, negative 1, negative 2, negative 3, and you pick a point somewhere on that number line. Let's put it right here. What's the greatest integer less than or equal to that value? Well, the greatest integer, and integers are the numbers I have on the number line, no decimals, fractions. Alright, and the greatest integer that's less than or equal to that is 2. Alright, what if you pick a number, right here, really close to 1? Well, the greatest integer less than or equal to that is 0. Okay, what if you pick it at negative 1? The greatest integer less than or equal to that is negative 1. It's equal to it. But once you get off those integers, where are you always going to find the number that's less than or equal to it? You're always going to the left. So it stays at one value and then jumps or steps to that next value. So for example, once again, just looking at the parent function, if I say what's f of 1, well, what's the greatest integer less than or equal to 1? 1. 1.5. So 1.5 is somewhere here on the number line. The greatest integer less than or equal to that is still 1. 1.99999. It's really close to 2, but it's still the one that's less than or equal to it is 1. And so if you look at this, all these values from 1 to 1.99999 give you an output of y. So all of these ordered pairs are 1, 1, 1.1, 1, 1.5, 1, 1.9999, 1. And so anything from x equals 1 to 2 almost is always going to be 1. So what we do is we draw this line, but at 2 it's open because it's not 1 anymore. What happens at 2? Well, at 2 it steps. So the greatest integer less than or equal to 2 is 2. To 2.7 is still 2. And once again, from 2 all the way on to 3, it stays at 2, and then at 3, what happens? It steps up. And so it continues this pattern. Alright, I threw a couple negatives on here to make sure you're clear. Negative 3.2. So negative 3.2 on this number line is over here. What's the greatest integer less than or equal to that? negative 4, not negative 3. Remember, you're going to the left. Same thing for negative 3.5, it's at negative 4, and negative 4.1, it jumps to negative 5. So that's the greatest integer function. And as I said, you can see as you look at this, this is a step function. If you do choose to graph this on your calculator, I just want to show you what it looks like. Once again, it's under Math, NUM, absolute value is 1. On mine, the greatest integer is 5. I think it's the same for you. It says INT. So you press it. I don't know if it'll do the double brackets or not, but we just want to do X. And then we graph it. Look what happens. Okay? So you're not going to see those open and close circles because it's not going to do that on the graphing calculator, but you can see where those functions are stepping. Okay? It is definitely not a continuous graph. So if you take this idea and you try to graph some other functions that are greatest integers, and these are still double brackets, I didn't put them in double brackets, I should have, but still greatest integer functions, can we still graph them? Sure. You just have to look at, now you have to add 1. One thing I have to be clear with, greatest integer is a grouping symbol, just like absolute value. So if I wanted to take the absolute value of x plus 1, and you plugged in, let's say, negative 3. You wouldn't take the absolute value of negative 3 first, you would take the absolute value of negative 2. And that answer would be 2. You don't take the absolute value of negative 3 and say it's 3 plus 1. It's inside the grouping symbols. I don't think anybody would ever make that mistake. But then when we start doing greatest integer, alright, and we start plugging in numbers, let's say 1.2 plus 1, you don't take the greatest integer of, what did I say, 1.2 plus 1? You don't take the greatest integer of 1.2 and then add 1. You work inside. So what's 1 plus 2, or 1.2 plus 1? Well, that is 2.2. And so what's the greatest integer less than or equal to 2.2? 2. So make sure that you do inside the grouping symbols first, and then take the greatest integer, just like you would with an absolute value. So on this one, we have, we're just going to do a T-chart. And so usually what I do is I don't, I think about this in terms of, what if I pick, 0? Well, 0 plus 1 is 1. Well, what if I pick anything from 0 to 0.9, repeating basically? Well, it's always going to give me, 1.1, 1 point whatever, all the way up to 1.99999, and the greatest integer of that is still 1. So everything from 0 to 0.9 repeating is 1. And then when I step up to 1, 1 plus 1 is 2. So anything from 1 to 1.9 repeating is going to give you that output of 2. And once you get 1 or 2 steps on here, you don't have to keep going because that repeats the process. So from 0 to 0.9, we should be at 1. So I'm going to go from here to here, and then an open circle at 1, 1. Because at 1, it steps up to 2. And then 2, so from 1.9, from 1.0 to 1.9, it's at 2. And then at 2, it's going to step up to 3. And so you don't have to go all the way across the graph. You can just get 3 or 4 of them on here. And that's good enough. And so there you go. And once again, on the graphing calculator part, you need to make sure that if it's inside, you put it inside. And there you go. So just like we had there. Alright, and then the last one, you got 2, and then the times the greatest integer of x minus 1. So once again, we can just do a T-chart and plug in, 0, and it's going to give you 0 back. So from 0 to 0.9 repeating, when you plug that in, it's going to be 2 times 0 minus 1, which is 1. And this one is, you are taking the greatest integer right away. So anything from 1 to 1.9 repeating, the greatest integer of anything between 1 and 1.9 is 1. 2 times 1 is 1. 1 minus 1 is 0. Or 2 times, I think I did that wrong. It is 2 times 1 is 2. 2 minus 1 is Oh, this one should have been -1. Sorry, I got all messed up there. So when I plugged in 0, 2 times 0, 0, 0 minus 1 is -1. When I plugged in 1 to 1.9, that's 2 times 1, which is 2. 2 minus 1 is 1. Sorry about that. And then 2, anything to 2.9 repeating would be 2. 2 times 2 is 4. 4 minus 1 is 3. And you can see these going up by 2. That's that 2 in front of the greatest integer. That's that stretch there. So from 0 to 0.9, we're at -1. Okay, and then at 1 it jumps up to 1 until it gets to 2, and then 2 it jumps up to 3, and then once again so on. And so if we plug this one in, we're going to do 2, go to math, integer, and then x, and then -1. So you can see that it has gone down to -1 there, and you can see the steps that are occurring are twice what we were doing before because the 2 in front of the x, the greatest integer. So there you go. That is it with absolute value and greatest integer function. Once again, please be very careful with this in terms of the greatest integer function, especially if you've never done it before. That you pay attention as to you're taking the greatest integer of what's inside that. So on the second one it's just x, on the first one it's x plus 1, so you have to add the 1 before you take the greatest integer function. Your homework is a worksheet tonight. I can give that to you in class tomorrow, or you can go ahead and print it off from the website. Thank you.